So in this video, I'm going to go over geometric mean, Pythagorean theorem, as well as factoring. Most of these problems come from the Geometry McGraw-Hill textbook. Okay, we're going to go ahead and start off with factoring. So when we're factoring, depending on how you learned in the past, one of the ways that I factor is factoring by grouping. And the way we do that is we take the first term, or the leading coefficient of the first term, and the last term. We take those two numbers and we multiply them, which gives us the value of. So the factors of 12 is what we're going to list. So we always start off with 1 and 12. I have 2 and 6, 3 and 4. And then from here, it's almost like we're going to read this equation backwards. I want to know which set of factors here are going to add to 13. And we see that it's going to be 1 and 12. 1 and 12 add to 13. So what we're going to do is rewrite 13x as a 1x or x plus 12x. So positive x plus 12x gives us 13. The 3x squared is still out front. The plus 4 equals 0 is still there as well. From here, we're going to input parentheses over the first two terms and the last two terms. And then from here, we're going to look and see what is our GCF. Between 3x squared and x, they have an x in common, so I'm going to take the x out. And what stays behind is going to be 3x plus 1. A good way to double check that you did that correctly is go back and multiply. X times 3x is 3x squared. X times 1 is x. Okay, so now we're going to go ahead and take a look at the second set. Here we're looking at 12x and 4. Only the first term has the x, so we cannot factor out a variable. But between 12 and 4, the GCF there is 4. So I'm going to go ahead and factor out a 4. And then we got to write what those leftovers are. 12x divided by 4 is 3x. And 4 divided by 4 is a 1. So I have a plus 1. I'm going to take a moment and come back and look and see inside the parentheses. I have a 3x plus 1. I have a 3x plus 1. Those should always match up. So I'm going to go ahead and write 3x plus 1. Those are gone. And then what I had in the outside of those parentheses, x plus 4, is my second set. This is still equal to 0, just as it was in the original problem. And the reason why it's equal to 0 is because we're going to come back and solve each binomial for what the x value is. From here, we need to take each binomial. So I'm going to start off with this first one. If 3x plus 1 equals 0, then I need to solve. We subtract 1 from both sides. That gives us 3x equals negative 1. And then both sides get divided by 3. And x equals negative 1/3. Then we got to come back and solve the second binomial. If x plus 4 equals 0, subtract 4 from both sides, and we get x equals negative 4. On problem 2, same process. We're going to factor, solve by factoring. So I take the first term, the leading coefficient of the first term, and I take the last term, 2 and 5. I multiply those to give me 10. Then I list all the factors of 10. And then it's almost like reading the equation backwards. I want to know which ones are going to add to 11, which is 1 and 10. Now this 11 is negative. It's a negative 11x, which means I need a negative 1x or negative x and a negative 10x. My plus 5 is going to remain equals 0 in the back. In the front, I still have a 2x squared. From here, I'm going to input those parentheses. The first set of parentheses, I need to know what is the GCF of 2x squared and x. And the only thing they have in common here is the x. So I'm going to factor out an x. And I'm going to put my leftovers in the parentheses. So this is a 2x minus 1. Once again, you can double check. X times 2x gives us a 2x squared. X times negative 1 is negative x. For the second parenthesis, notice how I have a negative we're starting off with. You never want to start off with a negative. So automatically, we're going to have to factor out a negative. And then we see, okay, well, what else do they have in common? They are both divisible by 5, so I'm going to take the 5 out. And only the negative 10x has a variable, the 5 does not. So the negative 5 is the only thing we can take out. Negative 10x divided by negative 5 is a positive 2x. 5 divided by negative 5 is a negative 1. Once again, you want to double check. Inside parentheses should always be the same. Since they are the same, we're on the right track. I'm going to go ahead and rewrite that 2x minus 1. Those are gone. And then I have my x minus 5. This is still equal to 0, which means our next step is going to be to take each binomial, starting with 2x minus 1, set it equal to 0. Add 1 to both sides, we get 2x equals 1, which means x has a value of 1/2, or you could put 0.5. The second binomial, I have x minus 5 is equal to 0, which means x has a value of positive 5. Once again, we're factoring here. I have a leading coefficient greater than 1. So I'm going to take my 7, and I'm going to multiply it with my 2. This is going to come out to 14. So I'm going to list my factors of 14. And I want to know which ones are going to add to 15, which is the 1 and 14. Now this is a negative 15, which means I'm going to need a negative x and a negative 14x. Negative x minus 14x is negative 15x. And then, of course, a negative 1 times a negative 14 is a positive 14. I still have my plus 2 equals 0. And I have my 7x squared in the front. I'm going to go ahead and put my parentheses in. Okay, looking at the first binomial, the only thing they have in common is the x. I'm going to take out the x, and I'm going to put what remains behind. So 7x squared divided by x is a 7x. Negative x divided by x is a negative 1. In the second binomial, once again, we're starting off with a negative, so automatically I'm going to have to factor out a negative. From there, it's a 14. The coefficient's 14 and 2, so the GCF is 2. I'm going to also factor out a 2, and I cannot factor out any variables because only the first term in that binomial has a variable. So negative 14x divided by negative 2 is now a positive 7x. And then positive 2 divided by negative 2 is a negative 1. Once again, I'm going to take a quick check, make sure we're on the right track. I have a 7x minus 1, 7x minus 1. They're both inside those binomials, so we are on the right track. So I have 7x minus 1. Those are gone. And then I also have the x minus 2. This is still equal to 0. Now I'm going to take this first binomial, set it equal to 0 so we can solve for the x value. Add 1 to both sides, 7x equals positive 1, which means x equals positive 1 over 7. Taking that second binomial, x minus 2, setting it equal to 0. Add 2 to both sides, we get x has a value of 2. Okay, on question 4, we have a 2x squared. So the coefficient of 2 times 3, that's going to come out to 6. So I have 1 and 6, 2 and 3. I do apologize, all of these were using ones as the factors to use. So we're adding to get to 7. There's that 1 and 6. We're going to rewrite 7x as an x, a positive x, and a plus 6x. We still have the plus 3 equals 0 and a 2x squared out front. Okay. We're going to go ahead and put in our parentheses. The GCF of 2x squared and x is x, which means the remainders are 2x plus 1. And once again, you can double check. X times 2x is 2x squared. X times 1 is x. Coming to take a look at the second equation. This time we have a positive 6x and a 3. Our GCF here is a positive 3. So then 6x divided by 3 is 2x. 3 divided by 3 is 1. Take a quick look. We have 2x minus plus 1, 2x plus 1. They're on the right track. So I'm going to go ahead and bring those down. And then I have x plus 3 still there, equal to 0. I'm going to take this first binomial, 2x plus 1, set it equal to 0. Subtract 1 from both sides, so I have 2x equals negative 1. Divide by 2, and that leaves me with x equals negative 1/2. Take the second binomial. I have x plus 3, set it equal to 0. Subtract 3 from both sides, and I get x equals negative 3 as my second answer. On question number 5, we're going ahead and shifting our attention to using the geometric mean. And you have two theorems. You have your altitude theorem and you also have your leg theorem. I always want to start off with altitude if possible, if it needs to be found. I recommend you label your triangle. So here, this is a leg. The y value is representing a leg. And this is across from the hypotenuse. So we see here is the 90-degree angle. Across the way is our hypotenuse. So I'm going to go ahead and label that. And then over here would be a leg on the right. And then in the middle, we have our altitude. Once it's labeled, I can see I have my altitude value. I have part of my hypotenuse, but I don't have the other part. So the first thing that I want to do is go ahead and find the rest of my hypotenuse. So finding x. This takes, the theorem says take the altitude, which is 3, divided over by part of the hypotenuse, set it equal to the other part of the hypotenuse over the altitude. Because the altitude is geometric mean, they're the ones that are across from each other. From here, it's a proportion to solve. So 3 times 3 is 9, equals 2 times x is 2x. Divide both sides by 2, and we get x has a value of 4.5. Next, we can go ahead and find our x. So now we know our z, because z is going to be 2 plus our x value, which we know is 4.5. So z equals 2 plus 4.5, which means z equals 6.5. Now we can go ahead and solve for our last variable, y, which is a leg. So this is the leg theorem. The leg theorem states you take the leg over the hypotenuse, and we set it equal to the adjacent part of the hypotenuse over the leg. So the legs are across from each other. That gives us y squared equals, and then you got to do that 6.5 times 2, which comes out to 13. And then you take the square root, and we get y has a value of 3.60, and then you have your 555, which I'm going to round to 6. Question number 6, same thing. Go ahead and label your triangle so you know what everything is. This is my 90-degree angle, which means across the way is my hypotenuse, which means this would be a leg, this is a leg, and here is my altitude. I'm going to go ahead and start off by finding the altitude. Now when we're finding the altitude, we need part and part. So if the whole thing is 25 and the right has a value of 6, 25 minus 6 comes out to 19. We're going to need that 19. Okay, so finding the altitude, remember it states altitude over part equals part over altitude. So this is going to give me x squared equals 19 times 6 is 114. And then you take the square root. We will get a decimal. That's okay. We get 10.6771. Okay, so this was our x value. Next, I'm going to go ahead and find the y value. So I look, the y value here is a leg. So we have to use the leg theorem. The leg theorem states you take the leg over the hypotenuse, and you set it equal to the adjacent part over the leg. So the legs are across from each other. That gives us y squared. 25 times 6, 150. Take the square root. Once again, we have a decimal, which is okay. 12.247. This next part, we're going to find the z value. So we see the z value is another leg. So once again, we're going to use the leg theorem. It states the leg over the hypotenuse equals the adjacent part, which is 19, over the leg. Legs are across from each other. We multiply, get z squared equals 25 times 19 is 475. We take the square roots and we get z has a value of 21.795. On question 7, we're asked to find the value of x. And so we see that we have a right triangle. Across the way is our hypotenuse. Since the hypotenuse is representing our value x, we know a squared plus b squared equals c squared. Our c squared is x. So 13 squared plus 23 squared equals our x squared. We want to take the square root of each side. So x is going to equal the square root of 13 squared plus 23 squared. Type that in the calculator and you get x equals 26.4197, or you could say x is about 26.42. Okay, so on this one, once again, here's our right angle, across is our hypotenuse, and this one we know the hypotenuse is 34. So once again, a squared plus b squared equals c squared. If you leave it in this format, you get 21 squared plus x squared equals 34 squared. And so if you're solving for x, we are going to have to subtract 21 from both sides, 21 squared from both sides. And that leaves us with x squared equals 34 squared minus 21 squared. And this is where, in our notes, I had us start off with. But in case you had any of you wondering why, this is why. And then once again, to get the actual x value, you're going to take the square roots. So x equals the square root of 34 squared minus 21 squared. X has a value of 26.7395, or if you rounded, you would round to the third decimal spot. The number before is a 5, so this 9 goes up, which means you're looking at 26.74. On this one, we have our isosceles triangle. We know it's isosceles because these are congruent. Since the segment down the middle is perpendicular going through the vertex. It's a perpendicular bisector. It's also serving as our altitude. Because of that, we know these are bisected. So the whole distance is 18. Half the distance is 9. In this case, we have our hypotenuse, and we're looking for the leg. So as mentioned earlier, the leg is going to equal the square root of the hypotenuse squared minus the known leg squared. And type it in your calculator. We get x equals 24.3926. Again, if you round to the third decimal spot, x is about 24.393. Question number 10. Once again, here is our hypotenuse because of the 90-degree angle. This one we don't know the hypotenuse value, so we're going to go ahead and say x is equal to the square root of the legs squared. There's some. And then here, type it in your calculator. If you go and you round to that third decimal spot, x is about 40.496. Once again, the hypotenuse, the biggest side, the longest side. So this value should be the largest value, which it is. Okay, on our next problem, number 11, here's our right triangle, our right angle across the way is our hypotenuse, which we know. So if we're looking for x, we're going to have to subtract. X is going to equal the square root of our hypotenuse squared minus our leg squared. Type that in. Lots of decimals here. We get x is about 7.746. Okay, on question 12, this is our 90-degree angle. So the whole triangle we can't look at because the whole triangle we don't know if it's a right triangle. But we do know this is a right angle and it's across from this side. So this is our hypotenuse. So we're really only going to focus on this part, or half the triangle. Because the triangle has a segment going through the middle, going through the vertex down to the base at 90 degrees, we can safely say it's a perpendicular bisector, which means this bottom piece is split in half. So the whole thing's 42. That means we have each side has a value of 21. So we have 2 of the 3 sides needed. We can go ahead and use our Pythagorean theorem. Our leg that we're looking for is going to be equal to the square root of our hypotenuse squared minus our bottom leg squared. Go ahead and type that in. And if you want to know how to take the square root without using your calculator, I'm so glad. We are going to be doing that in class next week. on these next three problems, we're asked to classify our triangle. We're classifying by their angles. So we have our three to choose from. And when you're justifying, this is because we're using the Pythagorean theorem converse. So we're going to take a look here at our first problem. Let's scoot it over. And as we mentioned earlier, our longest side is going to represent our C value. Okay, so it says we're still using that a squared plus b squared equals c squared. C squared is our biggest number. So in this first example, my biggest number is 20. So that's going to be the C. So what I want to know is 10 squared plus 11 squared equal to 20 squared. Once again, depending on your preference will determine your next step from here. Okay, I'm going to go ahead and choose to take the square roots. So what I'm looking at is the square root of 10 squared plus 11 squared equal to 20. This is why I only have to input one thing into the calculator. When I type this in, I get the square root of 10 squared plus 11 squared is 14.8661. And for it to be a right triangle, it needs to be equal to 20. Well, they're not equal. This 20 is too big, which means I have an obtuse triangle. And the next one, looking at my numbers, the 55.5 is my largest number, so that's going to be representing my C. So I'm going to go ahead and take my other two sides, 21.5 squared plus 24 squared, and I want to know if that's equal to 55.5 squared. Okay, once again, if you want to take the square roots, oh, I forgot my exponent. You can. So if I type square root of 21.5 squared plus 24 squared, I want to know is that equal to 55.5. Type it in, and I get 32.2219. And if I want it to be a right triangle, it's got to be equal to 55.5. I see this is not true. My C value is too big, which means it's an obtuse triangle. Sliding on over to my last problem here. I have 5 square root of 2, 10, and 11. Now, I'm not quite sure what 5 square root of the 2 is. I don't know if it's my largest number, if it's representing my C value or not. Go ahead and type it in. And we get 7. Oops. 7.071. So if I look at all these values, I see 11 is the largest, which means 11 is representing my C value. So I want to know, is 5 square root of 2, this whole thing squared, plus 10 squared, is that equal to 11 squared? Okay, once again, just so a few less things to type in the calculator, I can go ahead and take the square root of both sides, and in my calculator I'll just do one entry. Now make sure you have parenthesis 5 square root of 2, close parenthesis, squared. That's going to be key. If you don't have it typed like that, you're going to get the wrong answer. Go and type it in. And we get 12.2474, and that we want it to be equal to 11, but it's not. This 11 is too small, which makes our triangle acute. Okay, and this last question of our practice, it says the bottom end of a ramp is 10 feet from the base of the main dock, and it's 11 feet long. How high is the dock? And we were fortunate enough to have a picture provided. So we can see that it's 10 feet from the dock, it's 11 feet long. I want to know how high up it goes. So here, even though it's not telling us specifically, this is indeed a right angle, which means over here, the 11 is representing our hypotenuse. So just going back to using the Pythagorean theorem, we have a right triangle. We know two sides. We can find our third side. This third side is representing a leg. So our x is going to be equal to the square root of 11 squared plus 10 squared. Type that in. We get x is about 4.583. And this would be feet high. So the dock is almost 4.5 feet high, just over. All right, if you haven't already finished your exit tickets, please get those completed and turned in. Thank you.